This is a video that shows you how to perform an ANOVA using SPSS. What I have here is a data set. The first column is weight. It involves chicken weights or chick weights and the type of feed that was fed. So we have several cases, several types of feed. So we have 10 chicks that have been fed with horse bean, and the next 11 of them were fed with linseed, and so forth. Now the goal is to see if the average weight gained by the chick is the same across all feed types, or if there were differences in the type of feed, or based on the type of feed. Now if you're comparing only two feed types, we can do a two-sample t-test, but in this problem we have 1, 2, 3, 4, 5, 6. You have 6 different feed types: meat meal, casein, sunflower seed, soybean, linseed, and horse bean. So I want to know if the average weight of a chick is the same with respect to all feed. So to do that, what we do is we make use of an ANOVA, and assuming that all the assumptions hold true in this case, if I use an ANOVA, it will tell me if there are differences in feed types or not. So how do we go about doing this? So I could go to Analyze and select ANOVA from one-way ANOVA. And the weight variable is being selected already, but I'm not able to put in a factor. The factor is technically the feed type. So the feed type variable is totally missing in action from SPSS. So what happened? Well, SPSS is kind of weird while doing ANOVA, in that it has to code or recode the feed variable into numerical or pseudo-numerical variables. So in order to do that, we have to convert or transform the feed variable to a pseudo-numeric variable. Numeric in the sense it is numeric but not numeric. So the feed variable, when you first start, it will be on the left hand side, and if you move it to the right, you will see feed and transform it to question mark. So I'm going to give it a new name. I will call it feed underscore code, add new name. So what this transformation does is it's going to convert feed to feed code. And when you hit OK, and when you go back to the data set, you will see that you have codes automatically generated for each feed type. So horse bean is coded as 2, linseed is coded as 3, soybean is coded as 5, and so forth. It is a quirk that SPSS has in order to do an ANOVA. Now, if I go back to Analyze and select Compare Means and scroll down to one-way ANOVA, now I have weight, which is the dependent list. So we're going to compare the averages of the chicken weight or chick weight, and the factor now is the feed code, the 6 different feed types that I have. So feed code appears here after you transform it and you bring it over there. Now there are several other things that are involved within ANOVA, such as contrasting. You create contrasts, post-hook analysis, and so forth, but this video will just show you how to perform an ANOVA, and that is it. So I don't need any of these options. I can just hit OK, and you will see that it is quite significant. There are huge differences among feed types and the average weight of a chick fed with a particular feed type. So you can see that the F statistic or the F ratio is 15.365, and the significance level, or the p-value significance, is 0.000. So the p-value is very low, it's 0, so that would indicate that we reject the null of an ANOVA. If I reject the null of the ANOVA, I'm going to conclude that the average weight of a chick is actually affected by the type of feed. In other words, there are differences in the weight gained by a chick depending on the type of feed. So ANOVA can only tell you if there are differences or if there are no differences, but it cannot tell you what two feed types cause differences or which is the best feed type. In order to get that information, you'd have to perform what we call a post-hoc analysis, and that is for another video to come. I hope you can understand how to perform an ANOVA from this video. Thank you for watching.